Hi guys, I'm John Cedric Jimenez from BS AE221, and I'm here today to show you the project that I made for our subject Aircraft Systems. We were tasked to do a laboratory project that required us to make a scale model aircraft. Along with this, we need to show the different parts, construction, and function of each one. For my project, I decided to do the PA38, or most famously known as the Piper Tomahawk. Founded by brothers Clarence and Gordon Taylor in 1927, the Taylor Brothers Aircraft Manufacturing Company became Piper Aircraft 10 years after it was bought by a man named William P. Piper, who was otherwise known as the Henry Ford of aviation. The Tomahawk is a two-seat, single-engine, low-wing cantilever monoplane with a T-tail and is fitted with a tricycle landing gear for its undercarriage. The Tomahawk was favored among many CFIs because it was an aircraft that had realistic spinning characteristics and it was much heavier on the controls. This allowed pilots that trained with this aircraft to easily transition to more complex aircrafts. Tomahawks have been used in the Philippines, specifically in flight schools such as Airlink International Aviation School. The Tomahawk has a total length of 23 feet 1.25 inches, or 7.4 meters. It has a total height of 9 feet 1 inch, or 2.77 meters, a wingspan of 34 feet, and a wing area of 124.7 square feet. In doing this project, I had to scale down these sizes into an approximate scale of 1:23 as to meet the minimum length and wingspan of 12 inches on our guidelines. In doing so, this made the wingspan of my project to be 17 inches, its length is 12.5 inches, and it has a total height of 5.25 inches. The Piper Tomahawk is fitted with a rectangular cantilever low wing. This made the project easier since the ribs I had to make were all the same size. Unlike in a Cessna 172 or a Boeing 747, it has a tapered wing that has varying rib sizes. In this model, I made the wings starting from the ribs, the main spar, and also the stringers. On the underside of the fuselage, we can see the main spar, which is right here. This is one long piece that extends from wingtip to wingtip. This structure is made to absorb the downward stresses while on the ground, and when flying, the upward stresses on the aircraft. The ribs in this wing are the one that maintains the shape of the airfoil, and it supports the other members as well. The stringers, however, these provide extra rigidity and stiffens the skin in compression. For the tailplane of this model, we can see that it is designed with a T-tail type. The vertical stabilizer, which is this one, is made up of spars and stringers. As for the horizontal stabilizer, which is this one, it is made up of ribs and spars to have a shape much like the wings. The fuselage construction of the Piper Tomahawk, as we can see, it is a semi-monocoque design. It is fitted with formers, stringers, and longerons. The formers primarily establish the shape of the fuselage. The stringers are often attached to the skin where they carry a portion of the fuselage bending moment through axial loading. Longerons on the aircraft carry the stresses to the internal structure. These has larger loads than the stringers that helps transfer the skin loads. Overall, this project has helped me practice different skills and knowledge in regards to aircraft construction. Although it was quite challenging to build from scratch, in the end, it was fulfilling to have finished this project. Thank you for watching my video. I hope you have learned something new today. And as always, a good pilot is always learning.